So our topic is hypothesis testing. Hypothesis testing. We right to see that? Should you see that? Hypothesis testing is the process. Hypothesis testing is the process of confirming, whether the pre-existing opinion. Hypothesis testing is the process of confirming whether the pre-existing opinion, is true or false. About a given population parameter. So I think that hypothesis testing is the process of confirming whether the pre-existing opinion is either true or false about a given population parameter. Full stop. So that there are two types of hypothesis. So let me first of all explain, don't write. And number one, we have what you call the null hypothesis, denoted by HO. And then number two, we have what you call alternate hypothesis. Now, the difference between the two is that, now we are saying that hypothesis testing is all about confirming whether the pre-existing opinion is true or false. So, null hypothesis, now this is made first of all to cast the doubt. You see, in this case, you want to confirm whether it's true or false. So first of all, you have to cast the doubt. Now, casting the doubt is what you call the null hypothesis. And it starts from the negative side. So with the objective of triggering more information. Then, once you are satisfied with the information, that's when now you will be in agreement or you accept the opinion. And that's what we call the alternate hypothesis. So number one, we are looking at type of hypothesis. Number one, null hypothesis. And then you like to see that this is formed by casting the doubt. About the existing claim. This is formed by casting the doubt about the existing claim. Full stop. It starts from the negative. Point. And the objective is to trigger more information. It states that there is no significance relationship. There are no significant relationship between the variable. Yeah, we're saying that it states that there is no significant relationship between the variable. Good. So that's the null hypothesis. Number two, alternate hypothesis. Denoted by HA. Alternate hypothesis. Did you see that? This is formulated to be in agreement. With the current claim. This is formed or formulated to be in agreement with the current claims. Is the one which is accepted is the one which is accepted, is the one which is accepted. When null hypothesis is rejected, when null hypothesis is rejected, when null hypothesis is rejected, when null hypothesis is rejected. So now we look at types of hypothesis error. Yeah, what are some of the errors made of hypothesis error? You see that? There are two types, there are two errors made when performing hypothesis testing. There are two errors made. There are two errors made when performing hypothesis testing. When performing hypothesis testing. When performing hypothesis testing. Number one, we have type 1 error. We have type 1 error. Explain that. This is an error made. This is an error made. This is an error made when we reject, this is an error made when we reject the null hypothesis, when we reject the null hypothesis and the claim was true. We reject the null hypothesis and the claim was true. And the claim was true. We reject the null hypothesis and the claim was true. Number B, type 2 error. Type 2 error. Type 2 error, we have to say that. This is an error made when we accept the null hypothesis. This is an error made. This is an error made. This is an error made when we accept the null hypothesis, when we accept the null hypothesis, and the claim was false, and the claim was false. And the claim was false. Yeah, those are the two types of hypothesis error. So you're saying that we have type 1 error and type 2 error. Now this is what I mean. So here we have the parameter. We have the null hypothesis. Now this null hypothesis, you're saying that hypothesis testing is all about the process of confirming whether the pre-existing opinion is either true or false. So that means the claim can either be true or can be false. So when it's true or when it's false, as a decision maker, you can either accept or reject. You can either accept the claim or you reject. Also here, you can either accept or reject. Now, how does type 1 error arises? Now, type 1 error arises that the claim was true, but you rejected. So in short, you rejected a true hypothesis. Now, that's what we call type 1 error. Type 2 error arises where, in this case, the claim was false, but you accepted. So you accepted a false claim. That's how you make a type 2 error. You can show it. You said you show that. Eh? Now let's look at steps in hypothesis testing. Steps in hypothesis testing. Now, when conducting hypothesis testing, what are some of the steps forward? Number one, state the null hypothesis. State null hypothesis. You state the null hypothesis in bracket HO, in bracket HO. Number two, decide on the alternate hypothesis. Decide on the alternate hypothesis in bracket HA, in bracket HA. Number three, choose a significance level. Choose significance level. Choose significance level. In bracket, you show this alpha. In bracket, you show this sign, alpha. Then you explain, you see that? Let's try to see that. This is the probability. This is the probability of rejecting a true hypothesis. This is the probability of rejecting a true hypothesis. Probability of rejecting a true hypothesis. So that means, for example, you are conducting a research, and then you want to be 99% sure. That's what we call the confidence level. If you want to be 99% sure, now the question is, what's the probability of you making an error? The probability of you making an error is 1%. Now, this 1% is what we call the significance level, the probability of rejecting a true hypothesis. Number four, calculate the standardized Z or T statistics. Calculate the standardized Z or T statistic. Then number five, formulate decision rule. You formulate decision rule. Formulate decision rule. Then we explain to that. You formulate the decision rule. This can be either one or two tail test. This can either be a one or two tail test. This can be one or two tail test, depending on how. This can be either one or two tail test, depending on how the alternate hypothesis, have been formulated, depending on how the alternate hypothesis, have been formulated. So first of all, let me explain, don't copy. So I think that when formulating a decision, it can be either a one or a two tail test. How is it? Now, for a two tail test, it will look like this. It is formulated when the inequality is not equal to. This means not equal to. So it will be formulated like this. We have the normal curve like that. This is what we call a two-tailed test. So if your claim lies in between the unshaded region, that means you accept null hypothesis. If it exits, so that means lies on the shaded area, you reject the null hypothesis. Also here you reject the null hypothesis. Then, and in this case, how do we get the alpha? Now, in this case, the significance level will be alpha divided by 2. This is what I mean. If, for example, you wanted to be 99% sure, 99% sure, that's what we call the confidence level. So that means from here to here, should be 99%. So that means the margin of error is 1%. So that means this shaded part is 1%. But remember, I said that all this should be 100%. So how do you attribute this? So you take alpha over 2. If the margin of the significance level is 1%, so you divide it by 2. So this one will carry 0.5%, 0.5%. So that if you add that up, you'll get 100%. That's why you think that alpha over 2. So now that's the two-tail test. Now for a one-tail test, that's number B, a one-tail test. Now one-tail test is applicable whereby the alternate hypothesis inequality is either greater than or less than. Greater than or less than. So when it's greater than or greater than, it will be like this. Greater than. So here you accept the null hypothesis. Here you reject the null hypothesis. And in this case, you just take the alpha. So that means if you wanted to be 99% sure, so that means the confidence level, all this should be 99%. So that the margin of error, the remaining part will be 1%. But for a two-tail test, you divide it by 2, semantically. What if now the inequality is less than? The inequality is less than. When it's less than, this is how a one-tail test looks like. Less than. Less than, that means it's on the lower side. Like that. So here you reject the null hypothesis. Here you accept the null hypothesis. And in this case, alpha is meant to be alpha. Don't divide it into 2. So we are saying that number 5, you formulate a decision rule. So, and which can either be both either one or a two-tail test. So now let's start with A. Two-tail test. Two-tail test. See that number 5. Just write A. Two-tail test. Two-tail test. And to see that? Two-tail test. Then you show this. And this is the sign of not equal to. Sign of not equal to. Then you explain, see that? It's a test in which the alternate hypothesis is a test in which the alternate hypothesis is not equal. Statement is just to write this, not equal statement, not equal statement. You show like this, not equal statement, not equal statement. Good. Then from there, you can copy this. Also, you copy for one tail test for the 2. Let's do that. So that was step number 5. Now, lastly, step number 6. Step number 6. Accept or reject null hypothesis. You accept or reject. Accept or reject null hypothesis. That's number 6. Accept or reject null hypothesis. So now let's look at, those are the 6 steps followed in hypothesis testing. You identify the null hypothesis. Number 2, alternate hypothesis. Number 3, the significance level. Then you compute Z or T statistics. Then you come up with a decision rule. And then from there, it forms a basis of whether to accept or reject the null hypothesis. Now let's look at characteristics. Characteristic of a good hypothesis. Characteristic of a good hypothesis. Characteristic of a good hypothesis. Number 1, generality. 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 Then we like to see that. You see that? It explains the general phenomenon. Should explain the general phenomenon. Should explain the general phenomenon rather than a single occurrence. 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 Number 2. Number 2. It should be plausible. Should be plausible. Yeah, plausible means making economic sense. It should be plausible. Then you explain that. The hypothesis should be making economical sense. The hypothesis should be making economical sense. Economical sense. Another characteristic. It should be specific. It should be specific. Should be specific. Then we explain that. A good hypothesis should be specific, meaning that the concepts are clearly defined. Meaning that the concepts are clearly defined. Another one, it should be testable. Something you can be able to test. Should be testable. Should be testable. Another one, clarity. We explain that. It should be conceptual clear. Should be conceptual clear. i.e. free from ambiguity. Free from ambiguity. So now let's look at some terminologies. Sampling. Number 1 is sampling. What do we mean by sampling? It's the procedure of selecting a sample. It's the procedure of selecting a sample. It's the procedure of selecting a sample. Procedure of selecting a sample. So what is a sample? You know, a sample is a representative of the entire population. That's what we call a sample. Number 2, sample. We explain that. It's a small group. It's a small group of items selected. It's a small group of items selected. Small group of items selected from the population. Selected from a population. To act as a representative. To act as a representative of the population. To act as a representative. To act as a representative of the population. To act as a representative of the population. Number 3, parameter. Parameter, what do you mean by parameter? So that this measure used to describe, this is the measure, this is measure, the measure used to describe characteristic of the population. This is the measure used to describe characteristic of the population, characteristic of the population. Number 4, confidence interval. Confidence interval. Let me say that. This is the probability that the value falls. This is the probability that the value falls in between lower bound and upper bound. Lower bound and upper bound of a probability distribution, of a probability distribution, of a probability distribution. Good. Then let you see that. For CI means confidence interval. For CI, we use a two-tailed test. For CI, we use a two-tailed test. For CI, we use two-tailed test. So you're saying the confidence interval, eh? Interval, that means it's something in between, eh? So it's, for example, you have average. Assume average is that. Then you give it a margin of error. It can increase either by 5 or minus 5. So that means minus 5 can be 25, or it can increase with 5. Now, this is what we call now the confidence interval. It's all about the probability of being in between something. So that means when evaluating, you are conducting a confidence interval, you should always use a two-tailed test. All right, so that means if you use a two-tailed test, the significance level will be alpha over 2. Good. So now let's look at something else. Types of distribution. Types of distribution. Types of distribution. Number 1, Z-test distribution. Z-test distribution. Z-test. Let me say that. It's a test. It's a test. It's a test. It's a test which is used. It's a test which is used where the sample is a test which is used where the samples have been randomly, where the sample have been randomly selected, and the sample size is greater than 30. And the sample size is greater than 30. Full stop. Then let me see that. Z-test distribution assumes population follows normal distribution. Assumes that the population follows a normal distribution, Yeah, you remember in our distribution analysis, in our last session, that's probability. The last thing we did was probability distribution. That was normal distribution, normal curve. And we do something like that. So it's also assumed that the population follows normal distribution. It's evaluated as follows. So how do we get that? Now to get Z, you take X bar minus mu, you divide by standard error of the mean, which is equivalent to X bar minus U over standard deviation square root of N, where what's X bar, what's U, what's SE, what's that, what's that. So X bar is the mean of known population, mean of known population, or what we call the population mean. Then we have U is the mean unknown population. Mean of unknown population, or what we call the sample mean. Then we have SE, that's the standard error. Yeah, of sample mean. Standard error. Then N is the sample number. This is the standard deviation. So that was Z test. Then we have number 2, t-test distribution. T-test distribution. We write. This is used where the sample, this is used where the sample, this is used where the sample have been randomly selected, have been randomly selected from an infinite population, from an infinite or infinite, have been selected from an infinite population, full stop. It's applied where the sample size is less than 30 items. It is applied where the sample size is less than 30 items. Less than 30 items. Yeah, it's evaluated as follows. It's evaluated as follows. Formula is the same. That T, you take X bar minus U, standard deviation square root of N, where here we need to use degrees of freedom. T alpha over 2 N minus 1. So that where T significance level over 2 and then N minus 1. This one will enable us to read it from the table. I'll show you how to read it from the table. Yeah. Now this is what we call the degrees of freedom. Degrees of freedom. Where show that is degrees of freedom. And then we say that degrees of freedom is determined as follows. Degrees of freedom is determined as follows. Degrees of freedom is determined as follows. Degree of freedom is determined as follows. So in case of one mean, case of a two mean. Now, in case of one mean, to get the degrees of freedom, you just take N minus 1. See the way I've taken N minus 1. In case of a two mean, to get the degrees of freedom, you'll take n1 minus 1, then you add n2 minus 1. Then number 3, we have chi-square. Chi-square, denoted by that. Have a symbol for chi-square. Let me see that. This is used to compare attributes. This is used to compare attributes. Full stop. It's a test where which indicates it's a test which indicates the magnitude. It's a test which indicates the magnitude of the difference. It's a test which indicates the magnitude of the difference between observed frequencies and expected frequencies observed frequencies and expected frequencies under certain assumptions. First off, it's evaluated as follows. Think that to get the chi-square, you'll take the summation of observed minus the expected variation square, or of it you divide by A, where what is that? A means the summation. This is observed variation. A is the expected variation. And how do we get degrees of freedom? Now, degrees of freedom in case of chi-square, you take r minus 1, you multiply by coram minus 1, where df, you're saying, is the degrees of freedom. R is the number of rows. C is the number of columns. And how do you determine the expected? Where to get the expected variation, you take the row total times the column total. Then you divide by the grad total. So that's the fourth distribution. And lastly, we have, that's number 4. F-test distribution. F-test distribution. F-test distribution. Did you see that? This is used to analyze variance of the two samples. This is used to analyze variance. This is used to analyze variance of two samples. Variance of two samples. It's used to analyze the variance of two samples. Good. Those are the various type of distribution. Okay. Now, but the most common is the Z-test and T-test. And what's the difference between the two? It's very simple. For the Z-test, it's applicable where n is greater or equal to 30. In short, it's applicable for big sample size. For T-test, it's applicable for small samples. Small samples, that means where n is less than 30. This is for large sample, and this one is for small samples. But what you can observe is that the formula are the same. Z, it's x bar minus u over standard deviation square root of n. Formula is the same. Now, what makes them to be different? The difference comes in that for Z, we use the Z table, the one we did for normal distribution. Let's go back to your handout. Now, in your handout, there is a table like this, the one with the normal curve. This is what we call the normal curve. Just look for that. That's what we call the Z table. Not from the handout, from the first paper. It's in your question paper. I mean, question paper. It's just there, the other page. Just go. I mean, I've seen it. Just there. Yeah. That's what we call the normal curve. So, in case we're evaluating for large samples, we use that table, Z table. Then we have to T-test. Now, for T-test, there is another table. Look for a table like this. You have a table like this. Just look for a table like this. Good. So you have those two types of table. You see, the formula is the same. The only difference now comes when we have those two. Good. So now let's proceed. So those are the various types of distribution. Now let's look at subtopic, confidence interval. Subtopic, confidence interval. Confidence interval. We're right. This refers to the probability. This refers to the probability that population parameter. This refers to the probability that population parameter will fall between two set values, for certain probability distribution. This refers to the probability that population parameter will fall between two set values for certain probability distribution. For certain probability distribution. Full stop. Confidence interval measures confidence interval measures the degree of uncertainty, or uncertainty measures the degree of uncertainty or certainty in a sampling method. NB, NB, NB. For confidence interval, we use a two-tailed test. For confidence interval, we use a two-tailed test. It's evaluated as follows. So how do we get the confidence interval? Now, confidence interval will get the mean. Then you add the margin of error. Which, this is what it means. Mean, it's X bar. And how do we get the margin of error? So to get the margin of error, depends whether it's a small sample or large sample. So it can either be T or Z. So it's Z, so it's plus, sorry, this one should be mean, plus or minus margin of error. So it can either be plus or minus. So here will be in form of formula now, it's X bar to represent the mean, then margin of error is Z or T, standard deviation, square root of N. Yeah, this one is when N is greater or equal to 30, or for small sample, it will be X bar plus or minus. For small sample, we use T test. So it's T, standard deviation, square root of N. This is where N is less than 30, of which we are saying that Z, standard deviation, square root of N, or T, standard deviation, square root of N, which is what we call the margin of error. Margin of error. Can do an illustration. Illustration one. Here to see that a sample of 100 fluorescence tubes. A sample of 100 fluorescence tubes. A sample of 100 fluorescence tubes from XYZ Limited, gives a mean length of 20.5 hours, of 20.5 hours, gives a mean length of 20.5 hours with a standard deviation of 1.6 hours. With a standard deviation 1.6 hours. Full stop. Required. Find a 95%. Find a 95% confidence interval, and interpret the result. Find a 95% confidence interval and interpret the result. Good. So can you read that question again? Read the question again. So you're told that. So now this is a solution. You're told that a sample of 100. So N, it's 100. First tube from XYZ Limited Company gives a mean length. Mean is the average of 20.5 and a standard deviation of 1.6. Now the question is, find a 95% confidence interval. We want to be 95% sure. If you want to be 95% sure, what's the margin of error? The margin of error will be 5%. So since N is greater than that, so we use Z test. So to get the confidence interval, its x bar plus or minus can either increase or reduce by the margin of error, which is z standard deviation square root of n. So we have x bar, which is 20.5 plus or minus. How do we get z? So we compute z, then we multiply by the standard deviation. So this how we get z. You see that for confidence interval, we use a two-tailed test. So here we have the mean. The mean is 20.5. So it can either increase or reduce by a given value. So how do we determine that value? So in this case, Z, I take you back to the normal distribution. See that under normal distribution, all this area, the probability is 1, of which this is 0.5, this is 0.5. We want to be 95% sure. That means the significance level will be 5%. If you want to be 95% sure, so that means probability of making an error of the margin of error is 5%. So this one you take alpha over 2. So in short, in a maanisha that all this will be 95%. What's the probability of you making an error? It's this, the shaded part, of which we said it's alpha over 2. So it will be 5 divided by 2. Therefore, it will be 2.5%. So in short, you have to take this. We know all this is 0.5. So this is the shaded part around. We are saying it will be 2.5%. 2.5%. Now, can we be able to get this probability? So to get that probability, you'll take 0.5. You eliminate this 2.5%, which is 0.025. And that's what you'll do here. To get Z, you'll take 0.5, all this half, 0.5. You minus this 2.5%, which is 0.025. What do you get? 0.475. Now, this is the probability of this. This is the probability. So what we need now is Z. Now, in our last class, we computed Z. Z is equals to x1 minus x bar over standard deviation. And then when we get the figure, to get the probability, we read the table from the table. Now, in this case, we have the probability itself. Now we need its Z. So how do we read this Z? To get the Z, you don't read it from the table, you read it inside the table. Inside the table. So can you go to the Z distribution curve? Z, normal curve. Go to this normal curve. The one with the Kaugari there. So hoping you are there. Now, go inside the table, not from the table. You know, from the table, this is how you are reading it. You are reading maybe 2.40. Now, in this case, that's not what we want. You already have the probability. We wanted Z. So, ingia huku ndani, itafutie 0.475. Then give me the coordinates. That's what we mean inside the table. 1.96. Good. So this one you get is 1.96. 1.96. So that's our Z. So our Z, we have already computed, it will be Z is 1.96 times standard deviation of 1.6 square root of n. N was 100. So it will be 20.5 plus or minus. Now give me the margin of error. Give me the margin of error. It can either increase or reduce by how much? Into 2 decimal places, 0.31. So that means can increase or reduce by 0.32. So now give me the upper control limit and the lower control limit. This is what I mean. Upper control limit, you take 20.5, you add 0.32. Lower control limit, you take 20.5 minus this. So what do you get? Sorry? 20.82 is not be 20 points. That one 8. So that means the minimum it can go is 20.18 and the maximum it can go is 20.82. So that means the confidence interval will be between 20.18 and the maximum it can go is 20.82. So that means that we are 95% sure that the sample mean will lie between 20.18 and 20.82. Good. You can copy now. Z test. This case, we're not doing Z test. We are doing confidence interval. We have not gone to hypothesis testing. We apply Z and T in hypothesis testing. This is not hypothesis testing. This is confidence interval. Yeah, this is the confidence interval. And try another illustration. May 2018, question 2C. May 2018, question 2C. May 2018, question 2C. Mwanaisha Ali sells tree seedling at Mavuno Market. A random sample of 9. So N is 9. So if N is 9, that means it's a small sample, it's less than 30. So we use a t-test. A random sample of 9 of the seedlings had the following height in centimeters. So we're given the heights required. A 95% confidence interval of the population mean height of the seedling. So how do we get the confidence interval? X bar plus or minus. Now in this case, since the sample size is less than 30, we use a t-test. T, standard deviation, square root of n. Now the question is, do we have X bar? That means the mean. Do we have the standard deviation? Do we have the n? N is 9. So how do we get the mean? Mean is the average. So can you add the total heights? Then you divide by 9. Add the total, you divide by 9. Add the total, you divide by 9. What do you get? 63.8. Then you also need the standard deviation. How do we get the standard deviation? Now, to get the standard deviation, you take the summation of x minus x bar squared, all of it, n minus 1. Since the small, the population says it's less than 1. So this is what you'll do. For example, x is the height. So you take 64, you take 62, you take 65, all that up to 9. Then you minus X bar is 63.8, 63.8. Then what you get, you square, then you add all of them. Once you get the total, you divide by n minus 1. Our n was 9. So you take 9 minus 1, which is 8. Then what you get, now you get the square root. That's how you get the standard deviation. Or alternatively, you can use a calculator. You can use a calculator. So take out your calculator. Using calculator, get the mean to get the standard deviation. First step, you clear. Shift mode 3 equals. Shift mode 3 equals. I hope you have cleared. So how do we insert the formula for standard deviation? Press mode. Can you see standard deviation? SD. Its number? Press that too. Good. Then how do we insert the data? So now let's go back to the height we have. The first one was 64. Press 64. M plus. 62. M plus. 65. M plus. Do like that. You put the figure M plus. You put the figure M plus like that. I have said that you press mode, then standard deviation, which is number 2, you press number 2. Then to insert the figure, you'll be pressing, for example, the first one is 64, you press 64, M plus. The second one is 62, M plus, like that, until you get n is equals to 9. until you get n is equals to 9. Good. So is n is equals to 9? Now press on. Press on. Good. So how do we get, first of all, let me confirm whether your x bar was correct. Press shift. Number 2. Can you see x bar? Its number? Press 1 equals. What do you get? Sorry? That means this one was wrong, right? You're getting how much? Okay, how much are you getting as your x bar? 63.77, eh? Yeah, so that means this one is correct. Let's repeat again. Press on. Press on. Shift number 2 again. Shift number 2 again. Let me ask you again. Did you got 63.8 or you got 64? That's what you are getting, eh? What about when you have added the total? Now assist me with your calculator. Let me compute myself. Assist me with your calculator. So I need to confirm the two. So 64, you add 62, you add 65, you add 63. I hope the honest students are following because I cannot see anyone even posting the answer. So that means they are not computing. So then you divide by 9. So this is 64.89. That's what I've gotten from the total. Now let me use a calculator to use the same. So we had 64 m plus 62 m plus 65 m plus 63 m plus 68 m plus 69 m plus 65 m plus 63 m plus 65 m plus. So shift number 2, number 1, and I get exactly what I got. You see now the problem when I say that use your calculator. Muliachie moja compute. Na mkasema yes ni hivyo. Ndio non confirmed. Hakuna mwenye notice it was wrong. Yes. So also this one you are getting this. So now how do you get the standard deviation? Shift number 2. Shift number 2. Now if you press shift number 2, we have x bar. This is number 1. Then number 2, we have something like that. And then number 3, others are showing SX, others are showing like that. So the difference between 2 and 3, both of them, they are standard deviation. But number 2 is a standard deviation for large samples. Number 3 is a standard deviation for small samples. So you'll not be given data which is more than that, and you're not given the standard deviation. So always be using number 3. Always be using number 3. So can you press on? Press on. Shift number 2. Shift number 2. Then 3 equals. Shift number 2, 3 equals. What do you get? 2 point? 3, 2. Okay, what are you getting? Sorry? You have cleared and I have done the correct thing. So 2.3? 3, 2. So that's the standard deviation. So that means to get the confidence interval, the x bar, we have standard deviation, we have n. So what we don't have now is t. So how do we get t? Now to get the t, so that for confidence interval, it's always a two-tailed tail. So the question was a 95% confidence interval. So all this, it's 95. So that means this one will be alpha over 2. 95, that means the margin of error is 5%. So it will be 5% divided by 2, which will be 2.5%. Then we know that all this half is 0.5. So we need this. So to get t, we don't use z table, we use t table. So t, n over 2, n minus 1. Remember, you see that. How do we get the degrees of freedom? Go back to your formula. I had given you the formula and a t-test, and a t-test. In case of a one mean sample, to get degrees of freedom with n minus 1. Now listen here. Alpha over 2, it will be 2.5. Degrees of freedom, it's 9 minus 1, you get 8. So let's go to our t-table. Go to our t-table. Use t-table. Use this table. Now, when you are there, listen here. This is 2.5 or 5 parts. You can use both. Angalia hapo juu you have 0.05 or 0.025. They are same. Just look at that. Angalia hapo juu in your t-table. This is what I mean. Look where you have 0.05 or 0.025. Can you see that? Then uteremuke up to where the degrees of freedom is 8. Up to where the degrees of freedom is 8. Give me that coordinate. You get? 2.306, correct. 2.306. So that means now we can get our confidence interval. So confidence interval is that you take X bar, the average is 64.89 plus or minus margin of error. You take T, our T is 2.306 times standard deviation. Our standard deviation is 2.32. Divide by the square root of n. Square root of 1 was 9. So it will be 64.89 plus or minus. Now, can you give me the margin of safety? Give me the margin of error. You got an amount of 1.78. So now give me the upper control limit and the lower control limit. Upper, that means you add, lower you minus. $66.67. $63.11. So that means the confidence interval will be 63.11, 66.67. What does that mean? That we are 95% sure that the mean height of seating, the mean height of the seating will lie between 63.11 centimeter and 66.67 centimeter. So you can copy. Take out your handout. Handout page 11, question 3. Handout question 3, page 11. Question 3, I told that where we have the confidence interval. Question 3. The standard deviation of weight of student in KCE college is known to be 1.5 kgs. That's the standard deviation. Determine the size of the sample, that's n. Determine the size of the sample necessary to estimate the mean weight of the student if the estimates is to be accurate within 0.5 kgs with 99% confidence. Read the question again. Read the question again. Yeah, the standard deviation is 1.5. Determine the size. So we are determining n necessary to estimate the mean weight of a student if the estimate is to be accurate within 0.5. Within 0.5. What is 0.5? Within. That's what we call the margin of error. It's 0.75. And how do we get the margin of error? The margin of error, we see that it's Z standard deviation square root of n, square root of n, as simple as that. So it will be, we have margin of error is 0.75. We have the standard deviation. What we need is n. Do we have z? So to get z, we see that for confidence interval should be a two-tailed test. So being a two-tailed test, it's 0.5 minus, we want to be 95% sure. So how much is the margin of error? Percentage. It will be, so it's 1%, which is 0.01. You divide by 2. Remember, that should be alpha over 2. So give me that. 0. 0.00 005 49. Then inside the table, read for me inside the table. Now let's go to the Z table, Z distribution table. Ingia huko ndani, you look for 0.49. It's not a must, should be exact. Not a must, should be exact. What are you getting? Approximately 2.58. So the margin of error we have is 0.75 is equals to Z. Z is 2.58. Standard deviation of 1.5 square root of n. Now what we need is n. So to get that, what we do? We divide both sides by 2.58. 2.58. So it will be 1.5 square root of n. So 0.75 divided by 2.58. You get? 0.29. Then we need this. So you multiply both sides by square root of n. So it will be 1.5 is equals to 0.29 times square root of n. Then you divide by 0.29, 0.29. So square root of n is equals to 5.17. So we need n. So how do we get n? You square. Good. So to get n, you take 5.17 square. Approximately 25 students. So you can copy that. We're looking at confidence interval for proportion. Confidence interval for proportion. Right, you see that? In case of proportion, comma, confidence interval in case of proportion, comma, confidence interval will be evaluated as follows. Confidence interval will be evaluated as follows. So CI, you take the proportion of the probability plus or minus Z, PQ over N, out of it you get the square root. Where, what's P, what's Q? P is the proportion. Q, it's 1 minus P. Q is 1 minus P. I do an illustration. The same page, handout page 11, question 2. Handout page 11, question 2. In a sample of 200 voters, 80 voters were in favor of reintroducing death penalty. Of the 280 were in favor. So what's the proportion? So the proportion is 80 over 200, of which you get 0.4. That means Q is 1 minus P will be 1 minus 0.4, which is 0.6. In a sample of 200 voters, 80 voters were in favor of reintroducing death penalty. 1. Find a 95% confidence interval for the proportion of all voters who are in favor of this opinion. You see, the sample is 200 voters, so we use a Z test. So find a 95% confidence interval. So how do we get that? So first of all, let's get Z. Now to get Z, so that for confidence interval, use a 2 mean sample. So to get Z, you take 0.5. If you want to be 95% sure, that means the significance level will be 5. So you take 5%, which is 0.05 over 2. Give me that. $4.7. Then inside the table, did you got 1.96? Inside the table. Let's go to the Z distribution table, 0.475. Is it 1.96? This is what I have done. You see that this is 0.5, this is 0.5. And here it's alpha over 2. 95% sure. So that means all this should be 95. So that means there is a significance level of 5%. So it will be 5 over 2 to get 2.5%. So to get this proportion, that's I've taken 0.5, you minus this probability of the shaded part 2.5, and that's what I have done here. So that means to get the confidence interval, it will be proportion, which is 0.4 plus or minus, that is 1.96 times PQ 0.4, Q 0.6, all of it to divide by N. There were 200 voters. Then this one will get the square root. So it will be 0.4 plus or minus. Now give me the margin of error. Zero point 0.07. So that means the maximum it can go is 0.47, and the limit it can go is 0.33. So that means the proportion will be lie in between 0.47 and 0.33. So that means if you want to be 95% sure for those who support introducing death penalty, it should be between that 3% to 47%. Number 2 of the question, 99% confidence level. So Z, you'll take 0.5. If you are 99% sure, that means the significance level will be 1%. So alpha over 2. So it's 1% is 0.01. You divide by 2. I'll give me Z. What will be the remaining probability? Zero point 495. Then inside the table, 2.5. So that means to get the probability, confidence interval is that is the proportion plus or minus Z PQ square root of n. So the proportion does not change. It was 0.4 plus or minus. Now Z has changed. 2.58 square root of P is 0.4 Q 0.6 N to 100. So it will be 0.4 plus or minus. Give me that. .09. So that means the upper control limit will be 0.49. Lower control limit will be 0.31. So that means the proportion will lie in between 0.49 and 0.31. So you can copy. So in our next session now we'll do hypothesis testing. We have not done hypothesis testing. We only introduced, then we have dealt with all the confidence intervals. So that means in our next session we do pure hypothesis testing.